So you know that we've got very expensive GPUs at the moment, even after the price of the 4070 allegedly dropped to about $599. So with the entire RTX 40 lineup being rumored around or basically revealed, we're probably not getting anywhere better in the RTX 40 series. It is understandable because we are basically in a inflationary environment, but in this case, I really suggest you not to buy the GPUs, even if they do get to the price where they are affordable, because according to the roadmaps, and things gonna be a big change in how we use GPUs in the future. And I'm talking about a big change literally in the RTX 5000. So ever since the GeForce came out, GPUs have been dedicated to graphics. In the old times, it has been very difficult for games to render a scene at 30 FPS, even if you drop the resolution to like somewhere around 800 to 600. Even game trailers back in the days were mostly 720p, and they're not even like the 2K, 4K like they are right now. Even the most powerful GPU has not been enough for artists to deliver what they wanted. So in order to get the game to actually run, developers really have to do a lot of things to keep things steady. They're just gonna do something like to reduce the polygons or to reduce the texture sizes and use a lot of other tricks to really offload the calculations to before the game even runs. For example, Resident Evil 3 would fix the perspective of the player so that they would see what exactly the developers wanted them to see, because there's a scene pre-rendered into the background image. So when you're playing the game, it looks like there's a lot of things inside of it, but really there's only a single image, with a very few objects that are actually interactable being rendered as a 3D object. In a lot of scenes, Jill is probably the only 3D models that you get in the entire frame. In that game, what you see is really not what you get. This technique is what usually called offline rendering. In the development phase, the heavy calculations is already done for you. And when you actually run the game, you can just simply take the results and put it in the game without the need to actually recalculate everything. But those things really require very steady conditions. In the case of the original Resident Evil 3, you basically have to use a fixed perspective in order for the whole scene to work. You're not gonna have the camera move anywhere. Another example would be Mirror's Edge in 2008, where it uses pre-baked light maps very heavily in the entire game, because the game is all about parkours and you're just running around the city like jumping among buildings. You're not really carrying a torch or doing any gunfires. And with those settings, the lighting conditions in the entire game is pretty constant, which made it very suitable to just bake the entire lighting conditions into the textures of the objects and then use those results directly when you want to play the game. So ever since we're into the post GTX 10 series, I mean all the way to now, you probably noticed that we're getting very little difference between generations of GPUs in terms of the gaming graphics, even if we do get better GPUs every year. Games nowadays already has very nice graphics if the studios are willing to push it. And the difference between the real-time rendering and offline renderings are really very subtle. In the past, there has been a great difference between offline and real-time. Now they look pretty much the same. You pretty much expect a real game to be like the exact trailers that you're seeing. And if you compare the graphics between GTA 5 Redux mod and Cyberpunk, those two things are 5 years apart from each other. Whereas in terms of the graphics, you can hardly say that there's any technological advances. While the designs in Cyberpunk, you might just like it a little more than what we see in GTA 5, but it's really something artistic instead of technological. So even if you want the two things to look the same, a more powerful GPU is probably not gonna do the job for you. Moving on to now, in the RTX, we even have GPUs that are powerful enough to do real-time ray tracing. You can even do real-time GI with Minecraft with just a GTX 1060. So if you're just trying to get more FPS out of your game, I mean when you're talking about 90 to 140, or when you're talking about reducing latency when those latencies are probably mostly not from your GPU, or you just want to pump up your resolution from about 4K to 8K, these applications are probably not going to have that much of an audience out there. Studios might have rooms to get away with less optimized games while still being able to run in actual consumer PCs, but still it's a very small industry, let alone if you're just talking about benefits of studios. So gaming is down anyway for Nvidia. Well, in today's games, even when we're only talking about the graphics, the bottleneck is actually not the raw power of your GPUs anymore. It's more about assets. We're already seeing top engines working on improving the workflow and shipping games faster. If you look at Unreal Engine, apart from Nanite and Lumen, it's also got MetaHuman that can capture human motions just with a phone. And they also get Megascan to get rid of the need for artists to model the terrain. And they also get some other procedural generations at the version of 5.2. Those are all about workflow improvement, and you probably can also get it to enhance your gameplay. But when we're talking about workflow improvements that we can get from the GPU, you probably know where I'm getting at. Yeah, I'm talking about artificial intelligence, specifically the ones based on deep learning models. What's important is these AIs can make one thing behave like the target with some uncontrolled variance in them. For example, if you use ChatGPT, the answer can vary from time to time. Midjourney's pictures can also be different even if your prompt is the same. We're seeing a lot of applications out there already, so whether you like it or not, it will get a boost. But at the same time, none of the RTX 4000s have that much VRAM for you to run all these models at the same time. Back in the days, we have DLSS and frame interpolation. Those were just a teaser of what you can do with a GPU. And when you start to talk about the non-graphical usage, like language models and something, you're gonna need a lot more VRAM than your current GPU has. Even if we're just talking about graphics, ray tracing can need tensor cores to generate SDFs on the fly. So if all this doesn't really happen with cloud computing, I mean, if the market actually decides that we're gonna do this locally, there's a chance that we might see a big change in the architecture that we use today. And that is more VRAM, more tensor cores, and less shader cores, because we're probably not going to shade like how we do today.